Okay, so let's start with day 6. Okay, so today we'll see the topic at set, right? Why set and the set methods, right? So how you basically define the set, right, in Python? Okay, so you can define the set like this: set A equal to. You can define it with the constructor. So let's say set A equal to set this, and you pass the value to it. Let's say you pass 11, 12, 34, right? So now this is constructor, right? So basically you are creating the case set with constructor. So first thing about set, that set will not store duplicate values. Okay. If you try to store duplicate values, like again you pass 44 here, again to the constructor you need to pass any iterable, right? Iterables can be again a set, again a tuple, or a list, right? So if you print now, you print set a now, if you right click and run it, you see set is printed. So 44 is removed, right? Because it does not allow the duplicate values. If you just try to print the type of it, you say set type of set A. You right click and run it. It will belong to class set. So this is the first. Right. The another way would be to pass tuple to it. Okay, so everyone knows tuple is basically a fixed length. Let's say so you pass tuple to the constructor, and again you will be getting the set. But again, it will only hold the unique values. Right click, run, see set with unique values. Next way would be pass another iterable to it. Another iterable we know will be another set only, right? Creating the set with the set. If you print again, let's see, let's see, you will be getting again unique values. We will not allow the duplicate values. The direct way of defining the set would be set D equal to curly braces. Right. Print set D. Again, unique values only, will not allow the duplicate values. So first time we pass set to it, list to it. Next time we pass tuple to it. Next time we pass set to it. Now here we directly defining the set. Do stores. So this is how you basically stores the define the set. So set does not stores the value by index. So let's say I define another set, and let's say I define a set of names. And if I print it, let's say I print names, click run. Save, right click and run. So I'm getting the set, right? But if I try to get it by index, right? So if I have to print like names of 0, I won't be getting it, right? Because it does not shows the value by index, right? See, I'm getting the error, right? Set object is not subscriptable, right? So you cannot have the value, or you cannot fetch the value by the index because it does not shows the value by the index. Yeah, I'll just comment out the other code. Yes, see. So then how you will basically identify, or how will you basically try to iterate, or basically find the values is there in set or not? Okay, so index will not help you, right, on this. So let's comment this out. Okay, so I have this set with me. So now there are methods or ways. So for example, this is set, right? And if you want to print every element of the set, everyone knows that there is a looping, right? So you can loop through it. So looping through set. How can you loop through set? So there's a simple way for looping through set, and the most easy way would be for atom in set. What is the name of set? Names print atom. You cannot use range function here because it does not show the value by index. So for atom in names means for atom in set, print atom. So if you right click and run, see, it will print every element of the set. Okay. Now, like the other data types, set will also have the methods. Okay. And the methods are useful to basically perform operations with the set. And there are many methods on the set. Okay. So we'll go one by one and check for the methods, right? So let's say if I want to check a particular element exists or not. Okay. So I'll say name dot. So these are the methods, right? For the set. See if I want to check whether if I want to add the value to the set, right? So if you try to remove the element, right? Let's say for example, there is a method called as remove, and if I pass purva to it, right? So it will basically remove the purva from the set, right? So let's start with this remove method. Okay. If I right click and run, and if I print the set again, let's say I am printing the set again, names, you won't see purva there. See? Just give me 1 minute. we might be having two windows, so I'm facing problem while running this. Okay, let's try now with this. Okay. Let's now rerun this. Okay. So now I'm getting the scroll bar. That's fine now. Okay. So if you want to basically remove the value from the set, though there is a remove method, right? Okay. But if you try to remove something which is not there, right? So it will throw you the error, right? Key error. Okay. That Purva is not there, right? So here, if you want to remove something with the element name, you can remove like this. So I say names dot remove Purva, so it will remove Purva, right? There is another method, names dot discard. Now this method is useful to basically check if the element is there or not, because it does not halt the execution. It will not throw you the error. If you try to remove something which is not there, it will not throw the error. It will just return you undefined. Okay. So if you basically store into a variable and you print again the names, you again printed the names, again printed the set. If I right click and run, see, it is not throwing you any error, right? If you just print Q1 and rerun this, it will give you the none, right? So this method, discard method, if you try to basically discard something which is not there, still it is not halting the execution of the program. It will just simply return you none. This method does not return anything. Okay. And if there is an element which can be removed, it will basically remove the element, right? So let's say there is a small Sarika here, right? Sarika is there in the list, right? So if you try to now print the names again and right click and run it, you will see Sarika will not be there, right? Yeah. So remove and discard. To both of these elements, you pass the element of the set only. Remove, if the element is not there, it will throw the error. Discard will not throw the error. So it will allow you for the execution of program. So it will allow you to the execution of programs. This will be cleared when we start with the exception handling. But for now, if you try to just understand this, remove basically removes the element, discard also removes the element, but removes if the element is not there will give the error, discard will not give the error. There is another method which basically help you with removing. The name of the method is pop. Now here the pop is random, right? So it will remove any element, any of the element, right? It will not specifically delete a particular element. Any element can be deleted. So if you want to delete the element randomly, because it does not show the value by index also. So if you print it, you can see any one element will be deleted. Now let's say our set only has three elements, that is Satish, Chinmay and Ram. If I right click and run this, see Chinmay and Ram is there only, right? Satish is deleted. So it does not delete the last element and first element like this because it does not store the value by index. It deletes any random element. So these three methods, remove, discard and pop. So these three elements are used to basically delete the values from the set. Okay, let's see the another methods. Let's say set A. If you want, let's say I define another set. I will define a set of cities, let's say cities, and the set of cities will have few values. Let's say Pune, Bangalore, Kolkata, Chennai. And if I want to add another city to it, also adding the another value to the set, there's the add method. So I will say cities dot add and cities dot add, and I'm adding. So here is Pune, Bangalore, Kolkata, Chennai, and I'm adding. Let's say here I am adding Nagpur. So if you print the set again, let's say print cities, right click and run, you will see Nagpur is added. Okay. Again, the values will not be added by index, so it can be added anywhere. If you see, there's an element which is Nagpur added to the set. Again, you cannot add duplicate values. So if you try to add again Nagpur, There won't be another entry because it does not allow the duplicate value. So here will be one Nagpur only. So to add element, we have the add method. Okay, let's again talk about this. Let's again have this below, and let's check the another method. So let's say if I say cities dot, so you want to update it, right? So you have the set already, you want to update it. Let's say update. So when you try to update, okay, you can again pass any iterable to it, right? Say I am trying to update this set with another set of values. So let's say I want to update it with Varda, Kolkata. No, Kolkata is already there, right? Chennai also there, Mumbai, Amravati, right? So now this city's already existing set is updated with the more values. So if I save this, if I right click and run this, see, now my set got extended with these values. Again to the update method, you can pass a list. Again to the update method, you can pass any tuple. Again to the update method, you can pass the another set. Let's quickly do that. Now I am passing the, instead of passing list, I am passing the tuple. So tuple will be a fixed length, again iterable, and to the tuple with tuple I am passing a city like Gaya. Then I am passing here the city. Now I am passing another set to it. And this time when I am passing the set, I am passing the city as Jaipur and Udaipur. Jaipur and Udaipur. Purpose is basically to update the values, to update the set, right? And if you right click and then you see the values are updated, right? So many values are added here. Okay, so it should be comma separated. Yeah, now it will update only Gaya. Yeah, fine. So one value cannot be tuple. So you should having more than one value. So comma. So this will be tuple. Okay. So this is the way we can basically update the tuple. Okay, update the tuple. Now there is a method which is called as clear. Right? So it will basically, it will not delete the memory as we have in other also in the other collection also. It will simply empty the what do you say, empty the set. So if I say cities dot clear, and if you print it again, if you print the cities again, you right click and run, so it will be an empty city. See, now it will be empty set. Okay, because you have simply cleared it. Then there is a copy method. Let's say for example we have set a, and I have set a defined as 11 22 33, and if I define, I say set b is equal to set a. See, I already told you. Now this time we are creating the reference, we are not creating the new memory, right? So if I delete something from set b, okay, I say set b dot pop was remove, and I'm passing the value 11. And so what I have done, I have defined one set. That set I have copied to the another set. So no separate memory is created. Both are pointing to same memory. We have discussed this before in list, right? Now if I try to remove something from set B and print both again, okay, so set A and print set B, I right click and run this. So 11 will be deleted from both, right? Say, why so? I'll quickly explain on the whiteboard one more time. I told this before, right? So if I have basically x here, x equal to 10. So behind the scenes, what is happening? Behind the scenes, there would be
a memory created.
memory created with the value x, and here it is 10. And if I say y equal to x. So another memory will be created, which will be again the address of the memory will be y and the value will be 10. So because the both memory are separate, so if I change something on the y, let's say I change it to 90, so x is not getting affected, right? I will be having here the value 90. So if you print x now, so if you print x, it will be 10. If you print y, it will be 90, right? But now this does not happen with the data types which stores more than one value. Okay. So this does not happen with the data types which stores more than one value. So let's say I define a set here, set A and having the value 11, 22, 33. Behind the scenes, what will happen? A memory will be created. Okay. A memory will be created. The memory does not store the value by index, so randomly the memory will have 11, 22, and 33. Okay, now if you try to basically, and the address of the memory is 100% set A, right? So if you try to copy set A into set B to set A, what is happening in this case? This is going into, so you, likewise here, the memory was created. Here, not set B memory is not getting created. Another reference from same memory, another address for the same memory is getting created. Okay, so now both of this, right? Both are this pointing to same memory. So this and this both are pointing to same memory. Now what happens if you try to delete something with this reference or if you try to delete something with this reference, it will affect both. Let's say for example, both of these references, I try to basically say set B dot remove and I say remove the 11 value. So what is happening here? This 11 is getting removed from this memory. Now you basically access it with set A or you access it with set B, no problem. The answer would be same, right? Because here there are separate memories. So removing or updating one will not affect the other. But here both are pointing to same memory. So if you update it from one, it will eventually affect both the references, both the addresses. This is the same. This is same with case for list. This is same with tuple also. Is this fine? In tuple, anyways, you cannot delete something, right? So not in tuple. So this is same case with the list also. We have already told you this before. Let's see. Okay. So now like you have basically set A and set B. Okay. So if I remove something from set B and if I print both, it will be removed. But now if I want to create a separate memory, so deleting from one will not affect the other, then there is a method and the method name is copy, right? So if I simply say set A copy and I store that in set C. So this time I created the copy and I stored that copy in set C. So if I print it, if I right click and run this, so it says, okay, just will comment out this because we have removed something from there. Okay, let's. Now this time I've created the copy of set A, right? So copy of set A means separate memory. Okay. So if I delete something from set C, let's say I say set C dot remove 11. So it will not affect set A because copy was created. And when the copy is created, the separate memory is created, right? So set A and set C, if I print it again, right click and print it again, you see it is deleted from set C only, not set A because copy was created. So this is a copy method which is useful here. Fine. Okay. Now let's say set A dot. Now copy, pop, remove, clear, update done, add done, discard also done. Now you have all the methods which are set, important to set. Okay. So these methods are interesting and you cannot remember this method, but because I have practiced it so many times, so I know their functionality. Okay. So let's take one by one. Okay. So we need to have multiple sets basically to have or to work around with these methods. Okay. And not that useful day-to-day life also, but we are taking the topic, we need to cover all the methods. Let's say, for example, intersection methods are there, union methods like this. So let's say set A, I have set A as 11, 22, 33, and I have set B equal to, let's say, 44, 55, and 66. And if I want to basically combine both of this, so what I will do, I will say set A dot union set B. Okay. So now it will basically combine both and return me a single value that I will store in set C. We'll say set C, and if I print set C, okay, and right click and run this, so I will be getting the sum of these two. So sum of these two and a bigger set means union. Okay. So this was the union method. Okay. Let's say there is an intersection method also. So this intersection method will basically give me the common between the two sets. Let's say I will again define these two sets below. Okay, this time deliberately making one common element across both, right? And if I try to say set A dot intersection set B, set A dot intersection set B, and I stored that same, and if I print and I store that same into, let's say, set C. So I'll be getting common across the both sets. So what is the common between this both is 33, right? So if I print set C, right click and run, so it is 33 here, right? There's another method which says set A. I'm just commenting this out. I am updating set A with the intersection of set B. So how you read these operations means you are updating set A. And you're updating set A with what? Between the intersection of set N and set B. So what is the result of intersection of set A and set B is 33. And I'm updating my set A only with the common element between two. So if you right click and again, or if you just print the set again, set A again. So set A is updated with intersection of this both. So intersection of this both is only 33. So set A is updated with 33 now. So it will be only holding one value, which is 33. This is also clear. Intersection update.
Yes.
Okay. Let's say we have another method here. Let's say, for example, okay. Let's check for again. I will basically bring this two again down. And what I will be doing, I will be checking the another method. So let's say set A dot. So intersection update done. Let's say difference. Okay. So set A difference set B. So this will give me how many values are different in set A with respect to set B. So if 33 is common, I think set A has 11 and 22 as different values. Let me store that into a variable. I will store that into a variable, let's say set C. And if I again print it, if I again print set C. So now difference. So what is the difference of set A as with set B? So difference is that 33 is common. So difference is this both 11 and 22. So if I say copy this again here, and if I run this, so I will be saying this is the difference 11 and 22. Is this fine? Now, if I want to update my set A, so set A dot difference update with respect to what? With respect to set B. So set A will be updated with the difference with respect to set B. So I'm updating now. So if I print the set A again, so I will basically see set A is been updated with respect to the difference as compared to set B. So these are the common values. So set A will be again only 11 and 22. See 11 and 22. So this is the method which is difference, and this is another method which is difference update. So we are updating the set A. Okay. So we are basically updating the set A with the difference with respect to set B. So only difference is that These are the common. So set A will be updated with 11 and 22. Okay. So there is another method. Let's again bring this back downwards and again check for the another methods. So I have the symmetric difference also. So let's say I say set A dot symmetric difference set B. So now this will basically return me all the elements which are not common, symmetric difference. So if you take out the 33, the elements which are not common among this both set are 11, 22, 44 and 55. So if I just store it into a variable called as set C, and if I print set C, I will be getting all the elements across both the sets which are not common. So if I say set C again, if I right click and run, see, we're getting all the elements which are not common. Okay, and now if I say symmetric update, so set A dot symmetric update set B means I am basically updating the set A with the values which are not common across both the sets, right? So if I print set A again, the values for the set A will be all the values which are not common across the both sets. So again 11, 44, 22 and 55 because other 33 is common across both. So this is symmetric difference. So this is another method which is symmetric difference. And we have symmetric difference update as well. Symmetric difference update. So obviously symmetric difference update gives me the elements which are not common across both the sets. Again, I am basically building it down, taking down. Okay. This time, let's say I say set A dot. Okay, so these are done. Okay, this card is on the disjoint. So if I, let's say I am defining set A and I'll say I have 22 here, deliberately making 22, 11, 1, 1, 2, 2, 2, and 3, 3, 3. And here I will be having 4, 4, 4, 2, 2, let's say 4, 4, 2, 2, and 3, 3. So there is no common element across both of these sets, right? So if I try to do set A dot is disjoint method is there, right? Set B. So if there are no common elements across both the sets, then only this method will return you true. Okay. So this return basically returns you the Boolean value is disjoint, right? And when it returns the true value, so this will return true value when there is no common elements between these two, right? So let's say if I store it into a variable, I will say set D, and if I print set D, okay. And if you right click and run, this should be commented. Okay, now right click and run. You see it will return me true value because there is no common element between two. But if I have the common element between two, then this method will return me the false value. Okay, is this joint? Now again I have two methods remaining. One is superset and one is subset. Okay. So let's say for example, I will quickly move to the board, right? So let's say for example, I have set A and the values in the set is 11 and 22. I have set B and the values here are 11, 22 and 33. Now you try to understand this. Okay. So set A and set B. So set A. So if I talk about set A, okay, all the elements of set A are already in set B. So you can say set A is subset of
B.
set B.
Yes.
Set B. But set B has all the elements of set A plus additional elements. So set B is superset of set A. Okay. If you try to understand it like in diagram, so let's say outer one is basically set B, right? it is set B, and this inner one will be, let's say, set A. So this inner one will have basically what? The inner one will have 11 and 22, and set B will be having additional 133. So set B is superset. So if I call out on the superset and subset method, so set B is superset of set A, and that will be true because set B is having all the elements of set A plus additional elements, and set A is subset of set B because all the elements in set B is already present in set A. Clear? So let's quickly jump back here.
Yes.
So if I say I will define one set, or I will define these two sets again for these methods, and deliberately I am making it common elements, and here in set B I will be having one additional, right? So if I say set A is subset of set B, so if you print it, output will be, right click, output will be true. And if you say print set B dot subset of
Subset of A.
set B is superset.
Super.
No, no. So what is the method name? Superset. Superset of set A. Again, it will be, if you right click and run, it will basically throw you the. Is this fine?
Yes.
Let's check for any method we miss. I think we have all covered everything. Let's see, subset, symmetry, difference, copy, union. This disjoint, difference, it's update, remove, clear, update, pop. Yeah. Okay. So there are few more methods which are generic methods, not on this. Let's say, for example, set A equal to, I'm defining it again. And if I want to find how many elements are there, so you can have the length method, which will basically tell you the length. If you print it, you will get the length. If you right click and run, you will basically get the length. There will be a max method, which will basically give the max value from this set. Let's try to run that also and print it. So what is the max value from here? I think 33. So we basically save it and run it. I think you will be getting 33. See, 33 is the max value from the set. And if you basically try to get the minimum value, so minimum value of set A, the minimum value from the set A will be 11. So if you right click and run this, you'll be getting 11. These three additional global methods works with list as well, tuple as well, set. Clear?
Yes.